Good morning, fellow students. We are welcome again. In our last class, we were working with functions and mappings and relations, and we started functions in the last class, and we ended up with the domain of a function. I illustrated quite a good number of things. I said, if you are asked to calculate the domain of a function that is not a fraction, you just equate the thing to 0 and solve. Then the domain will be in a set of real numbers. But if you are given a fraction, you take the denominator, equate to 0, and solve. Then the domain now will take all elements excluding that particular answer. That is what we did in the last class. I gave a series of activities. I've not received any. I've also added more activities. We look at the next thing we have here. The next set of activity is to find the domain of the following functions. The first function, 1, f such that x is mapped to 5x plus 3. 2, g such that x is mapped to 2x plus 5 all over x minus 1. 3, h such that x is mapped to 5x squared minus 25. F, h such that x is mapped to x plus 1 over 2x plus 1. That is the next set of activity that we do, and you add to the other ones that I gave you. If you have any difficulty, let me know. Alright, that's that for what we did in the last class. I just added more. Now we are moving to the composition of a function. Composition here is the same as a composite, the composite of a function. So here I'll mostly be solving. So we need to know more about the composite of a function. What is composite? Compose, like you hear of a compost when they are making manure. It means you are putting so many things together now. Compose, the composition of a compound in chemistry, composition of elements and so on. All those things means you are putting so many things together. So in mathematics, we talk of the composite of a function or the composition of a function. We are referring to a case where we are bringing 2 or 3 functions together, right? 2 or more functions together. We bring them together, we now form the composite of functions. Okay, so we take down the lesson titled Composite of Functions or Composite Functions. We will now start taking down our notes. As I read, you copy. Consider, that's paragraph, consider the functions f, g, and h, comma. The composite of these functions denoted. You see the composite now. You denote the function. You denote the composite of the function using a small 0, or you link the function by multiplication sign. What I'm saying here is, if I have 2 functions f and g, the composite is either written like this: f with a small 0, g, or you write f of g. Okay, when you have that, is a composition. So I said denoted f composed with g, or f of g, is evaluated by considering the functions on the right first. So you always start, there are 2 functions. If I have to find f of g, you start with the one that's on the right now. This on the left. You are right. You start with g, and then you are moving to the left. Okay? Now when I say to the left, Melissa will start laughing. Now, we are going to look at a small example on that. Look at what happens. We have been given something. Consider the functions f such that x is mapped to 3x plus 4 and g such that x is mapped to x plus 2. They say 1. Express f of g of x, g of h of x. This should be g of f of x. Sorry. G of f of x, f of 3 in a similar manner. Okay. Like I told you in the last class, when you are given a function like this, you should not be afraid. Just transform it by writing f of x equals 3x plus 4. G of x will be x plus 2. Okay. Now we start solving. First question, we have to find f of g of x. How do I do this? Recall I said the function on the right comes first. So I have my f of g of x implies I will go to f of x everywhere I see s, I put g of x. Okay. I know my f of x as 3x plus 4. So here my result will now be 3x is g of x plus 4. Okay, like I said, we have f of g of x. You go to f of x, everywhere you see x, you put g of x. Okay, and here. So at this point, I will now open out. So you have 3 g of x plus 4. That's what I have as my result. But now what is g of x? I have g of x in the equation. My g of x is x plus 2 plus 4. Okay, now I'm going to open out. This time this will give 3x. This time this will give 6 plus 4. So my result now will be 3x plus 10. So I'll now write f of g of x equals 3x plus 10. I'm done with the first part of that question. right? So now go to the second part. The second part now is g of f of x. Okay, my board is misbehaving, so I'll use the other section. G of f of x. Okay. Okay, like I was saying, I'm now moving to g of f of x. That's the second part. How do I get this? Now look at it. I know my f of x according to my equation that was given to me. According to the equation that was given to me, my f of x is 3x plus 4. Okay, my g of x is x plus 2. Now I want to look for g of f of x. G of f of x here means you are going to go to g of x. Everywhere you see x, you put f of x. So this will simply be my g of x is x plus 2. So I'll just have f of x plus 2. That's all. Okay. So in that case, I will now look for f of x. It's there already, 3x plus 4. I'll put it 3x plus 4 plus 2. So the square my answer is 3x plus 6. Okay. That is it for g of f of x. Then the last part of the question requires us to calculate f of 3. F of 3. F of 3 simply means you go to f of x everywhere you see x, you put 3 now. So in this case, I'll have 3 times 3 plus 4. 3 times 3 is 9. 9 plus 4. The result is 13. Okay. That is it. That's how you do it with functions. So I'm going to give one last exercise. Recall I gave you 3 problems in the last class. I've added 4 for the domain. Now I'm going to add 1 for composite functions. Then you work with them and submit your results for me to correct. So the last activity now, which is enjoyment, says given the functions f such that x is mapped to 3x plus 5. Next, g such that x is mapped to x plus 1, all that divided by x plus 2. Evaluate, okay, 1, f of g of x, 2, g of f of x, 3, okay. The third part now, like I said, 2 is g of f of x, 3 will be g of 2. Alright, that's the last exercise I'm expecting you to solve and send your results to me for corrections. Okay, it's been nice working with you guys. I'm so impressed with Annie. The rest of you should follow suit and always make sure you do your exercises. Have a nice day and see you in the next class. Thank you.